Okay. Last week we talked about Maxwell equations and how can we derive some consequence from Maxwell equation, which include the energy conservation law and the time average quantity. For example, Poynting vector, time average the Poynting vector and the time average energy density of the electromagnetic wave.我离远一点，我离远一点。I also mentioned the boundary condition, which is which is essential when we want to derive the reflection and refraction coefficients of light between two media. So today I want to introduce two important issues about the electromagnetic wave. The first one is the vector properties of the electromagnetic wave. The other is about pulse. If we want to study the pulse propagating inside the medium, we must superimpose different plane waves to form the wave packet and observe how it evolves. So first of all, let's talk about the vector nature of the electromagnetic wave. 你们看这里会比那里还更清楚，对不对？因为这边比较暗一点，啊，我尽量写在这，不行的话就写到那里去。OK， 好。So now we use the complex vector representation to represent the electromagnetic wave. We can write, we use the complex vector. We use the complex vectors to represent the E and H fields. Okay. If we want the realistic electromagnetic wave, we just take the real part of this complex representations of these waves. So first of all, let me assume that the wave is monochromatic waves. Mono means single value. Okay. Chromatic, monochromatic means single frequency. Only one frequency. Okay. So assume the angular frequency is omega. Omega. Only one omega. Then corresponding to this omega, we have this lambda wavelength. And wavelength is equal to the wavelength is how to say? Usually, we introduce the wave number. Wave number is more useful than wavelength. Wave number is this quantity, okay? And the vector wave number is called wave vector. Wave vector. Here the S is the direction of the wave vector. Okay? That with this omega and this K, we can write the electric field as E0 exponential I omega t minus K dot R. Okay. Here, the S is the unit vector along the propagation direction. Okay. Here the small s hat is the unit vector along the propagation direction. And we can also write the h as h0 times exponential I omega t minus k dot r. Okay. Here, E0 and H0 are time-independent, constant, complex vectors. Okay. So now we want to see what is the relation between the direction of E, H, and K. Okay. So we use Maxwell equation, the Faraday's equation. Faraday's induction law is written as this one. And we also have the Ampere's law without charge current. Which can be written like this. And we know that B is epsilon times E, and B is mu times H. 这个真的有点奇怪，为什么会这么敏感？喂，好，我换一支看看。If we look for the right-hand side, equation 1, equation 2, right-hand side of equation 1. We know that B can also be written as can be written as this. And the B can be written as this. Okay. So according to this result, the right hand side of equation 1 is minus mu partial t partial h. However, now h is this. So this is I omega mu h0 times exponential factor, which is nothing but I omega mu times h. Okay, so the right hand side is simple. So how about the left hand side? To study the left hand side, we must be able to calculate this. This. And now this part is dependent on time, which is nothing to do with the curl operation. So we can factor it out. And then we have this. Okay. So if you remember from vector analysis that when we calculate a quantity like this, here f is a scalar function and a is a vector field. Then we have this identity. This is equal to gradient f cross a plus f times curl a. If you do not know this identity, you can just expand both sides and check its correctness, or you can reference the textbook to find this formula. Now what is f? This phase vector is f, and this E0 is the a. However, E0 is a constant vector, so curl a constant vector is equal to 0. So we have this exponential I omega t gradient exponential minus I k dot r cross E0 plus 0. This part is 0 because E0 is a constant vector. So what is this? What is the result of this operation? To obtain this result, we notice that del operator is 我不要用 ijk， 我用 xyz 好，因为 k 现在是保留给 wave vector 来用啊。Because now we use k to represent the wave vector, so I do not use ijk as the unit vector along the xyz direction. I use xyz hat as the unit vector along the x-axis, y-axis, and z-axis. So we have x partial x plus y partial y plus z partial z. Here x hat, y hat, and z hat are the constant unit vector along the axis. Cross, not cross, the exponential minus I. Remember that now k is a vector, so k has three components, kx, ky, kz, and r is the vector notation to represent the position. Okay, it has three components, x and y and z. So this is equal to kx times x plus ky times y plus kz times z. Okay. Here kx means k times sx, ky is k times sy, and kz is k times sz. Sx, sy, sz are the x, y, z components of the s vector. S vector is a unit vector along the propagation direction. So when we do the partial derivative to this function, okay, we get minus ikx. This is equal to minus ikx times x unit vector. And if we do the y partial derivative to this function, we get minus iky y hat, and minus ikz z hat times the original exponential vector. Okay, so this is just minus I times k vector times minus I k dot r. Okay, here k vector is kxx hat plus ky y hat plus kz z hat. Okay, so we have this. When we do something like this, we can remember that we can just replace the del of minus ik. Okay, we can replace del with minus ik, and we can replace the time derivative partial t can be replaced by I omega. Okay, once we encounter the monochromatic wave represented by complex vector, then we can replace the partial derivative with respect to time by I omega, and the partial derivative, the del operator can be replaced by minus ik. Okay, so we use this replacement and we apply it to these two equations. So the first equation tells us that minus ik cross E is equal to minus I omega mu h. And the second equation tells us that minus I K cross H is equal to I omega epsilon times E. Okay. So we can drop the minus I omega. And get these two equations. Okay. So if we consider the isotropic media isotropic 的意思就是各个方向的行为都一样。Isotropic means that every direction is equivalent. There's no difference along different directions. Okay. So for isotropic medium, we have epsilon and the mu becomes two constant numbers. Okay. Because if we consider an isotropic medium, epsilon and mu must be treated as tensors. However, if we consider isotropic media, epsilon and mu reduce to constant numbers, scalars. Okay. So we consider this situation. Then this equation. What about these two equations tell us? We know that we can write K as K times the unit vector S. So if I write E as E times the unit vector U1 and H as H times unit vector U2. Here E means E0 就是这里面的 E 和 H 已经含有那一些 phase vector， 我把它简化了啊。Here E and H are in general complex valued functions. Okay. So we substitute these two results, these two answers to these two equations. Then we find that K S cross E U1 is equal to omega mu H U2. Okay, and K S cross H U2 is equal to minus omega epsilon E U1. Okay, so this result tells us that K E is equal to omega mu H, and K H is minus, no, not minus. KH is omega epsilon E. Okay, and S cross U1 is equal to U2, and S cross U2 is minus U1. Okay, so this means that suppose this direction is S and this direction is U1 and this direction is U2. Then we have this S cross U1 is along the direction of U2. And the S cross U2 is along the direction minus U1. Okay. In fact, we have another two equations tell us more information about the directions of U1, U2, and S. The first equation is divergence D equal to 0 because now we have no charge. And isotropic medium means that this is divergence epsilon times E. And we also assume homogeneity. Homogeneous means that epsilon and mu is position independent. 它们不随位置改变，所以微分的时候可以拿到外面去。So we have epsilon times divergence E. And divergence B is equal to 0, which is equal to divergence mu H. And since mu is a constant, we can factor out mu, and we have divergence H here. So according to our thumb of rule, we can replace the del by minus ik. From this equation, we obtain this relation. K dot E is 0. And from this equation, we find that K dot H is 0. However, we know that K is not 0, E is not 0, and H is not 0. So we see that S dot U1 is 0, and S dot U2 is 0. This result tells us that we have a transverse wave. Transverse vector wave. Transverse vector wave. 好，横波。好，横波这边，所以这两个式子告诉你的是说 ，U1 垂直 S， 然后 U2 又垂直 S， 然后这边又更进一步告诉你说 U1、U2 本身也垂直。好，就说 This result tells you that U1 is perpendicular to S, and this tells you that U2 is perpendicular to S. And this two equation further tells you that U1 is perpendicular to U2. So we have this triad. 这个三个就是变成一个右旋坐标系的三个基底，好，两垂直，好，两垂直，所以我们会得到一个是横波。横波的意思就是说，我现在电场的方向是垂直于传播方向，因为 S 是传播方向，好，然后 U1 是电场方向 ，U2 是磁场方向，好，两垂直，好。So we have a transverse vector wave that means the E field and the H field vibrate at the plane perpendicular to the propagation direction, the S direction. Okay, and we can further obtain that from this. When we multiply these two equations, we get K squared is equal to omega squared times mu times epsilon. Okay. Now we have k squared equal to omega squared times mu times epsilon. However, what is k? K is this. Okay. K is 2 pi over lambda. This lambda is the wavelength in the medium. And what is omega? Omega means 2 pi nu. Okay. So from this we have lambda nu 1 over lambda nu square is equal to mu epsilon. So we have lambda nu is equal to 1 over mu epsilon. But what is lambda nu? Lambda nu is lambda over t. Nu is 1 over t, the frequency. Lambda over t means the speed of the wave， 就波的速度、速率、传播速率。波的传播速率就是 v，v 就是在一个周期内传播一个波长。So sorry. Here we have a square root. Okay, square root. So according to this result, we know that the wave speed v is equal to 1 over square root mu epsilon. And if we consider empty space, or vacuum, we have v equal to 1 over square root of mu 0 epsilon 0. Okay. Mu 0 epsilon 0 are the mu and the epsilon in the empty space. Okay. And this result is just the light speed in vacuum. 这个299,792,458公尺每秒，约等于3乘以10的8次方公尺每秒。好，这个精确的数字299,792,458是后来国际上定义出来的。用这个反过来去定义1公尺是多长。好，那我们只要记得就是说它大约是30万公里每秒就好。3乘以10的8次方公尺每秒。OK， 好，这是关于平面波，然后波的速度We can further find the relation that remember that we have k squared is equal to omega squared times mu epsilon. So we know that 1 over mu epsilon is equal to omega squared over k squared, which means that this quantity is equal to omega over k. Okay. Now, however, what is omega over k? This is the phase velocity. Phase velocity. 好，我们在这边讲这个 wave speed 的时候呢，其实是有点含糊的。事实上，波的速度有分好几种。In fact, the speed or velocity of a wave, there are different different kinds of wave velocities, which we can use to describe the behavior of the wave. The simplest one is the so-called phase velocity. Phase velocity means that we observe the wave, the monochromatic wave. We observe the monochromatic wave propagating inside the medium, and we count. We observe how the valley or crest of the wave propagate， 就那个坡峰跟坡谷的那个传递速度，就是所谓的像速度。We observe the fixed phase shape, how this fixed phase shape propagate. The velocity of this propagation is called phase velocity. However, there is another kind of important velocity. If we add many time waves to form a wave packet, then the center of the wave packet propagate in some velocity. This velocity is called group velocity. Vg, group velocity. Okay. If the medium is non-dispersive, then phase velocity will be the same as group velocity. However, if the medium is dispersive, then usually phase velocity is different from group velocity. OK， 好，就是看这个介质有没有色散。如果有色散的话，像速度跟群速度会不一样。好，那我们看，比如说三棱镜为什么能够把白光分成这个不同的色光，走不同的路径啊？其实就是因为玻璃是有一点色散。啊，色散的意思就是你的折射率会跟你的频率有关系。好，折射率跟频率有关，所以你的像速度会跟频率有关。好，会跟频率有关，不是固定的。好，那这种就属于有色散的介质。那如果在一个有色散的介质里面呢，你去算这个群速度跟像速度，通常就会不一样。好，所以 in a dispersive medium, usually group velocity and phase velocity are different. Okay. 好，那接下来我们要看一个问题，就是这个 pointing vector 呢跟它们的关系。Now we want to know how to represent the time average, the point vector for a monochromatic wave. Remember that we have the time averaged pointing vector. I denote it as this. This is equal to 1/2 real parts E cross H star. Okay. So now if we have E, here E and H are the complex representation of the electric and magnetic field. Now E is E0 times exponential I omega t minus k dot r. So according to Faraday's induction law, we find that minus ik cross E is equal to minus I omega mu times H. So now we know what is H. H is K over omega mu cross E. This is the complex vector of H by means of K and complex representation of the E. So E cross H star. Now we assume that the medium is non-dispersive, dissipative, no loss, lossless medium, lossless medium. Lossless medium means that it will not absorb the EM energy to become heat. So in a lossless medium, the epsilon, mu, K are all real quantities. 在一个不吸收能量的介质里面，这些全部都是实数，所以 H is also real quantities, real vector. Since H now is a real vector, E cross H is just equal to E cross H star is just equal to E cross H. 其实不能这样讲哈，等一下，这边我要重新讲一下，因为我现在这个 H 是含 phase vector， 所以我不能这样说哈。好，我应该这么讲哈。K 是实数，但是现在因为 E 含 phase vector，H 也含 phase vector 啊，所以它 in general 不是实数哈，这边错了哈，它仍然是 complex 啊，所以这边我们就变成是 E 去 cross 什么东西呢 ？E cross omega over mu K over omega mu cross E star。 好 ，E 现在是 complex，E is now complex vector, but K is real vector. Okay, so this tells us that according to vector analysis, when we consider A cross B cross C, we get A dot C times B minus A dot B times C. Okay, so we apply this formula to this situation. We find that E cross H star is now equal to E dot E star gives us the absolute square of E and times K minus E dot K times E. However, we know that E is perpendicular to K, so this is equal to 0. So we have the time average Poynting vector equal to 2 omega mu E0 absolute square times K. Okay. So we have this result. Okay, we have this result. There is an important quantity called impedance, which we may use it sometimes. The impedance is defined as the E0 over H0. Okay, we have learned that K E0 is equal to omega mu H0. So we have eta as omega mu over K. Omega mu over K. So this just give us E0's absolute square times S over 2 eta. Here eta is called impedance. Impedance 这叫做阻抗，阻抗。In vacuum, eta 0 is equal to, and this is in fact equal to this, this one. You can check this result. Okay, so in vacuum we have this quantity. The value is about 377欧姆左右。好，我们这边先下课一下，先下课，下课10分钟。